All right, this is lesson 6.7 from the AP Calculus BC book. There's a topic here that's actually also done in the AB part. That's the summation notation. So if this is something you think, hey, I've seen before, you're right, you have. It's actually in one of the AB videos. So I'm not actually going to do this part again with you. You can go back, and I think it's in the lesson 6.8 AB video, the early transcendentals version. I guess I'll put a link in the description part of the YouTube portion there, so you can just go directly to that. Okay. I also made a supplement to this as well. So if you want to get more in depth as to where this formula came from and why, then you can watch my supplement video as well. And I'll put a link to that there as well. But really, the BC topic for this section is this thing called integration by parts. So this is what I want to show you, and this is a BC topic. It's usually an extra topic that the AB students do after the AP exam, but for the BC students, you bet you definitely need to know it. So integration by parts is a method of integration used mainly for products, okay, of algebraic transcendental functions. So this is where you have two things multiplied together, and this time I'm asking you to do the antiderivative or the integral of it, okay? So here are some examples: x times e to the x dx, or this other one, e to the x times sine x dx. So how can we go about finding these integrals? Well, to do that, I want to go a step back and just review how we actually found the derivative of two things that were multiplied together. Yeah, do you remember the product rule? Do I need to sing the song to you again? Say no. I heard no. That's good. Okay. So we won't sing it again, but if you remember, it's, here's your A and here's your B. So A prime, I would call that du dx, right? A prime B plus B prime du dx times A. All right. Now, here's what I want you to do next. I want you to take the integral of all this. So the integral of dx of uv, and once again, if I do the integral, I need that dx notation after that, right? Which means I want to do the integral of du dx with a v. I'm going to put the v in front, okay, and then with a dx like this. And I'm going to also do the same thing here. So I'll put the u in front, dv dx, and then of course there's also a dx. Okay. Now, hopefully you'll see that when you simplify the left-hand side, this just becomes, well, what's the derivative of the integral? Those are inverse functions, so you're just left with what you started with, uv. And then here, you'll see that the dx and ds kind of can cancel out, so you're like, hey, I've got this thing, the integral of v du, and then I have over here plus the integral of u dv. And I guess now if I were to try to isolate the u dv part, so let's just keep this part here on the right-hand side, I would take this integral of v du and move it to the left-hand side. So I get this, u times v minus integral of v du. And you're thinking, so what? Well, here's what I'm saying to you. Look, look, look. If you have two things multiplied together, okay, you can call one of them u and the other thing called dv, then you have this nice formula. The integral is actually equal to u times v. So the u function times the v function minus the integral of v du. Okay? And this is the formula for the integration by parts method. All right? And if you look at the next page, there you go. Okay? You'll see the u and the v minus integration of v, and then this one says u prime dx, but I actually prefer this version over here. Okay? Now, you have to memorize this formula. Yes, there's another thing you have to put on that formula sheet. But I have a nice way of hopefully helping you remember this. I like to call this UV. When I hear the words UV, I think of the word ultraviolet. Okay? Ultraviolet light? No, no, no. We don't want ultraviolet light. I want ultraviolet VDU. Or how about, say, voodoo? So if you're looking at this at Halloween time, ooh, scary stuff, ultraviolet voodoo. Okay? And hopefully that will be a way to help you memorize this formula. Okay? So when you do these questions where there's two things multiplied together, your strategy here becomes you need to write one part as u and the other part as dv. So let u be the part whose derivative is the simpler part. Okay, it's something that you can easily differentiate. Okay, and then dv is really the more complicated part, or the stuff that is easily integratable. Okay. And once again, there's only two choices here, so really it's 50-50. If one method doesn't work, then you try the other one, okay? But if you're also curious if there's a way to determine which ones you should do, which ones you should choose for the u function, the answer is yes, there is. And the other thing that you might want to remember is this word called limit, okay? L stands for the word logarithms. So this will help you figure out what to let equal to u. If you see a logarithm, let that equal to u first, because we know how to do the derivative of a log, but we don't really know how to do the derivative of natural log. Well, we might be able to do that, but it's pretty hard. Okay? So if you see logarithms, always choose that as u, the function you can take derivative. I stands for inverse trig functions. I don't know if you know, but I don't really remember the integrals of inverse trig functions, but I do remember the derivatives of trig functions. So there you go. P stands for polynomial. So the third thing down this chain would be if you don't see logs and you don't see inverse trig, then choose polynomials as your u value. Then finally, E stands for exponents or exponentials, right? And then finally, T, you guessed it, trig. Trig is the last thing you should choose for u, because usually taking the antiderivative of trig is not too bad. Okay, so ultraviolet voodoo and lipit, those are what you need to know for integration by parts. So let's look at these examples now. Okay, so here's our first one. It's the integral of x times e to the x dx. So once again, I see two things, right? You have to decide which one is going to be your u and which one's going to be your dv. Ultraviolet voodoo. And I'm looking at this list, lipit. Do I have logarithms? Nope. Do I have inverse trig? Nope. Do I have polynomials? Yes. X is a polynomial. So I'm going to treat that as u. And then remember, everything that's left over becomes dv. So what's left over? It's e to the x dx. Okay, that is my dv. Okay, so let's go back and fill this in. What's du? What's the derivative of x? Yeah, it's just dx. Okay, and then the antiderivative of e to the x dx. So, what function when I take the antiderivative? It's also e to the x? Yeah, it's just itself. So therefore, now what I can do is I can rewrite this product of two things, x times e to the x. I can rewrite it using the idea of ultraviolet voodoo, uv minus v du. Okay, so I'm going to write this in now. U is x, v is e to the x, minus the integration of v du, so e to the x times dx. There you go. And you're thinking, well, that's a little bit complicated. I know, but look, that first part is already done. And now you have a simpler integral. What is the integral of e to the x dx? Well, that's just e to the x, right? And remember, this is an indefinite integral, so of course we need to add a plus c. There you go. Done. There's your answer. Okay? All right, let's take a look at example number 4. X times sine 3x dx. Okay, so once again, we have to figure out u and we have to figure out dv. What is u? Hello, lipit. Do I see logarithms? Do I see inverse trig? Do I see polynomials? Ding, ding, ding. I do. So u equals to x. Once again, du is just dx. And then dv is what's left over. So that's sine of 3x dx. So we need to anti-differentiate that to give v. So what is the antiderivative function of sine? I believe it's negative cosine. But wait, this is 3x, so we have that factor, the chain rule factor. We have to get rid of that factor of 3. How about putting a 1/3 in front? Good. And now, just like the previous one, we're ready to rewrite this using ultraviolet voodoo. Ultraviolet x times negative 1/3 cosine of 3x minus integration of v negative 1/3 cosine 3x times dx. Let me just write this a little bit nicer here for us. I'll write this as negative 1/3 x cos 3x. The two negatives become a positive, so plus 1/3 cos 3x dx. And now, like I said, you have a simpler integral, and we can just go ahead and take the antiderivative of that. But before I do, I better copy down the thing in front. Ooh, that 1/3, I'm going to take it out because it's a constant. And now I just want to do the antiderivative of cos. Oh, I know what that is. That's sine, right? Sine 3x. Oh, wait, there's an extra factor of 3 I have to take care of, so another 1/3 in front here because of, once again, yeah, it's a function within a function. It's u substitution. And then don't forget, I'm done the integral now, so plus c. So once again, if you want to write this nicer, negative 1/3 x cosine 3x plus 1/9 sine 3x, and then plus c. Ta-da! There you go. Okay, number 5. Arc sine x. Once again, look at the list. Lip it. Let's go down the list. Logarithms. Inverse trig. You bet. Ding, 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 ding. We have a winner. U equals to arc sine of x. So before we do the derivative here, what is dv then? What's left over if I have arc sine of x as u? You're right. What's left over is just the dx. That's it. Okay? So here are your two components, arc sine of x and then dx. Okay, so let's go back and find du. The derivative of arc sine, of course, is 1 over root 1 minus x squared, and then don't forget dx. And then if I asked you to find the integral of dv, that would just be, yeah, ding, x. Awesome. Once again, ultraviolet voodoo, uv minus integration of v du. Scared yet? U is arc sine of x times v is just an x, okay? Minus integration of v, which is x times du, which is 1 over root 1 minus x squared dx. Let me just try to rewrite this nicer. That's x times arc sine of x. And then, uh-oh, something's interesting. I get minus x over root 1 minus x squared dx. And you're like, but this is not actually an easier integral. And I'll say, yes, it is. Yes, it is. Yes, it is. Yes, it is. Because now I hope you can use one of your other integration strategies to help you figure out this part. Yeah, your good friend u substitution is coming back. Yeah, 1 minus x squared would be the stuff I think you should let equal to u. You're like, oh no, not this again. Uh-huh. What's du dx? Negative 2x. I can then solve for dx, right? Dx equals to du over negative 2. I guess I should put x down there too, right? Yep. And then if I were to make that substitution, so once again, I'm just focusing on this part here now. This becomes minus the integral of, I guess I still have x. This will be root u, and my dx becomes du over negative 2x. And that is perfect because look, the x's cancel each other out. That negative with the negative 2 can simplify to become just a positive 1/2 outside of the integral. And then I have the integral of root 1 over UB. And remember, that's the same thing as u to the negative 1/2, so that's great. Okay. Now don't forget, you still have this over here, right? X times arc sine of x, that's still there. But now you can take the antiderivative of this, so u to the negative 1/2's antiderivative is just u to the half with an extra divided by a half, which is multiplied by 2. That's nice, but I'll get rid of that 1/2 in front. And then I have, don't forget, plus c. So let me just copy all this stuff down. And let's write this a little bit nicer. So x times arc sine of x. The 1/2 times 2 is just 1. I'm going to replace the u again. U was 1 minus x squared. And this is to the power of 1/2. I'll just write this back as a root. And then now, don't forget, plus. Ta-da! Your answer. Cool, hey? All right. Feeling better about this? Good. 2 more examples today, and then we're done. I'm going to let you try example 6. I want you to start this at least, okay? I think you can start this. I have faith in you. You can start this. Okay? So think of the same process of Lipit, do ultraviolet voodoo, and let's see what happens. So I would press pause so that you can actually do this yourself, and then when you get stuck, I know you won't get stuck, but if you do get stuck, then press play and see what happens. All right? Okay, go for it. Integration of sine is negative cosine, right? I have to get rid of that 2, so 1/2 cos 2x. Okay, so I'm ready for ultraviolet voodoo, right? Ultraviolet voodoo. Ooh, scary. Ultraviolet voodoo. U is x squared times v, negative 1/2 cosine of 2x, minus integration of v, negative 1/2 cosine of 2x, times du 2x dx. Let me just simplify this. Negative 1/2 x squared cos 2x. That part looks good. The two negatives here become a positive, and then the half times 2 is just 1. So just positive integration of x times cosine of 2x dx. Now, if you got to this step, I'm quite happy. I will give you a round of applause. Can't really seem like there are applause, but you're not done yet, that's why. How do you then go about taking the integral of x cos 2x dx? How do you do this part now? Do I use substitution like the previous one? Nope. This also looks like x times something else, right? Two things multiplied together. Don't say it. Do integration by parts again? Uh-huh. I'll do that over here. Yep. U equals to x. U equals dx. dv equals to cos 2x dx. So v equals to the integral of cos is sine 2x, but 1/2 in front. Yeah, everybody. So here I'll use ultraviolet voodoo again. So u times v minus integration of v du. I guess I should bring down this as well. So negative 1/2 x squared cos 2x. All right, let's simplify this now. Once again, negative 1/2 x squared cos 2x. This is now 1/2 x sine 2x. And then now over here, I get, oh yeah, minus, I'll take out the 1/2. integral of sine 2x dx. Wow, let's do this again then. The integral of sine 2x dx. Oh, I've done that before. I know. That's just what? Cosine 2x? The negative in front with an extra half. Oh, I gotta write this again. Man, where's that copy paste function? I want that copy paste function right now. Brutal. And then finally, don't forget, you've done all your integrals, so plus c. So I guess I should write this one more time. Once again, copy paste. If you got this as your final answer, plus 1/4 cosine 2x plus c, bravo. Integration by parts, not once, but twice. Scary stuff. Okay, last one. This one's a definite integral, so I hope you remember how to evaluate definite integrals. Same process as before, except now you don't have to have that plus c, remember. You just have to then plug in the numbers and solve. So, once again, I'm going to let you try to start this, because I think you can do it yourself. Remember the idea of lipit to help you find u, and then also remember to plug in the numbers. Go ahead. You go it. Do it first. Once again, press pause, and then come back and double check your answer when you're done. Remember lipit? Yeah, so ln x is what you should be choosing for u. So the integration of 1 to e x squared ln x dx is uv. What is uv? u ln x v minus integration of v times du 1x dx. That simplifies to, I'm going to write down 1/3 x cubed in front, ln x like this. And then now this is now minus 1/3 the integral of x squared dx. I know what that is, right? Yeah, and by the way, I guess you are evaluating this, so you can put this all in a big bracket and write down the bar going from 1 to e. So you know you're going to evaluate this. Same thing here. We can keep doing that if you want. 1 to e. Let's go ahead now and actually do the antiderivative of x squared, which is 1, well, actually x to the power 3 divided by 3. So I'm going to combine it together to give me 1/9. Yes, yes, yes. And then now I can just evaluate and plug in the e. We'll plug in e first, so e cubed over 3 ln e minus e cubed over 9. And take away from that using the fundamental theorem of calculus, 1/3 ln 1. Nice, that's just 0, right? Minus 1/9. So how about e cubed over 3, because ln e is just 1, minus e cubed over 9 plus 1/9. Ding, 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 ding. Done. So now that you've practiced with me, now you have to practice without me. Let's start your assignment now. See you for the next video.